Hi everybody, I'm Mr. Bullock and this lesson's on properties of chords, this geometry lesson. I go kind of fast through these videos, so remember you can always pause it or rewind it if you didn't catch something, or if you want to pause it to take notes. So I'm going fast just to save time on these videos. Okay, so let's begin. Alright, so here's some theorems, you guys. So in the same circle or congruent circles, two minor arcs are congruent, and IFF means if and only if, you guys. It's not a misprint. This right here means if and only if. So two minor arcs are congruent if and only if the chords containing them are congruent. Well, what the heck does that mean? Well, this is what this means, you guys. If you have a circle right here, this is saying right here that this arc right here is congruent to this arc down here if and only if this chord right here is congruent to this chord. And if and only if means you can say it backwards. I can say this chord is congruent to this chord if and only if this arc is congruent to this arc. So it doesn't matter. That's what if and only if means. You can say them backwards. Okay, that's what that means. Okay, if one chord uh, is the perpendicular bisector of another chord, then the first chord is the diameter. Okay, so this is saying this. If one chord, this chord right here, BD, is the perpendicular, there's a right angle for perpendicular, bisector means it cuts it into two equal pieces, is the perpendicular bisector of another chord, then that first chord must be the diameter. So this has to be the diameter. If it's the perpendicular bisector, it's the diameter. Okay? If a diameter is perpendicular to a chord, then it bisects it. Okay, so here's a diameter BD. If this diameter is perpendicular, right angle to this chord, then, okay, let me do the then right here, then it bisects it. So then it cuts it into two equal pieces right there. Okay, so if it goes through the center of a circle and it's perpendicular, it bisects it. And also, if it goes through the center of a circle and it bisects it, then it's perpendicular. Okay, in the same circle or congruent circles, two chords are equidistant from the center if and only if their chords are congruent. Okay, picture for this is this. Okay, here we have two chords, congruent chords. Notice these chords are congruent with their markings right here. So if those chords are congruent, then they're equidistant from the center. So the distance is here, so the distance is always a perpendicular segment. So this distance is equal to this distance right here. Okay, that's all that theorem says. All right, let's try some of this, you guys. Okay, so in circle R, chord AB is congruent to chord CD, and the measure of arc AB equals the measure of arc, a measure of arc AB equals 108. Find the measure of arc CD. Okay, remember, if two chords are congruent, then their arcs are congruent. So if that arc, put the 108 right there, that's what this says right there. If that arc is 108, then so is the other one, you guys. If those two chords are congruent, then their minor arcs are congruent. So it's 108. Okay, let's try another one here. So here's section C. Find the measure of BF. Okay, it means the measure, the length, if there's nothing on top of it, you guys. So the measure of BF, all right? All right, so look, you guys, we have this diameter going right through here, and it's perpendicular. There's a right angle, so if a diameter is perpendicular to a chord, then it bisects that chord, so the other side's going to have to be 10 also. Okay, so BF equals 10. All right, so here's D. In the diagram, circle P, PV is congruent to PW, so here's PV, here's PW right here, and QR equals 2x plus 6, so this whole length is 2x plus 6, and ST, the whole length of ST is 3x minus 1. All right, so let's go ahead and mark that. It says PV is congruent to PW right there, so I marked it with those blue tick marks right there. And so since PV is congruent to PW and it's perpendicular, then that means this chord must be congruent to this chord right here, and that's what this says right here. All right, so then they gave us those lengths in terms of x, so 2x plus 6 equals 3x minus 1. So I'm going to solve for x, you guys. I subtracted 2x from this side and put it over here, and added 1 and put it over here, so it cancels nicely, and I get x equals 7. Now be careful, you guys. It's not asking for x. It's a real trick question, especially on SATs. That, you know, if it was an SAT question, I can guarantee you x or 7 would be one of the choices. It's asking for QR, you guys. So we got to plug in QR into right there for x equals 7. So 2 times 7 plus 6 equals 20. Okay, section E. Okay, so S is the point of tangency for circle U. Find R. Alright, okay, first of all, if this is r, this side's r over here, because they're both radii of a circle. And this tangency thing right there, that's code word for a right angle. So let's put that right angle right in there. Okay, so what that gives us is a right triangle right there. Remember that side's r. And be careful also, you guys, this is length r plus 36. A lot of people want to call this 36r. 36r means r times 36. These guys, you add these lengths together, so that's r plus 36. Then we're going to use the Pythagorean theorem, you guys. R squared plus 48 squared equals r plus 36 squared. And so there's r squared. There's 48 squared right there. And here's r plus 36 squared. Okay, now if you don't see where that 72r came from, then you forgot this rule, you guys. A binomial squared means you got to write it twice, and then you got to FOIL that out, you guys, and you get r squared plus 36r plus 36r, because you got to do outer times outer, inner times inner when you FOIL it out. Okay, then you combine those like terms and you get your 72r in the middle. Okay, so let's go ahead and solve that equation right there. Okay, now if I subtracted r squareds from both sides, they go away. So there they go, they're gone. So I'm left at 2304 equals 72r plus 1296, and then now we're back in pre-algebra. You subtract 1296 from both sides and divide by 72 and you get r equals 14. Okay, let's try one more, you guys. Okay, so it says OT and OM are tangent segments from, and so if they're tangent segments, then they are got to be congruent to each other, because tangent segments from the same outside piece are congruent to each other. Okay, so this is just a pre-algebra equation now. 6x minus 8 equals 25. You're going to add 8 to both sides and you get 32, and you divide by 6, and uh-oh, you get a fraction. Well, that's no biggie, you guys. Don't be afraid of fractions. 2 goes into 32 16 times, and 2 goes into 6 3 times, so the answer is 6/3.